Hi, everyone. Welcome to our session. My name is Jocelyn Bielko. I am your moderator of today's webinar. Today, we're presenting Logging and Observability in Elasticsearch Service, hosted by Anurag, our Principal Product Manager. He will be facilitated by Stuart Duncan, our Solutions Architect. Just a little housekeeping before we get started. If you have any questions during the presentation, please type them into the Q&A box located in the control panel on the bottom. Stuart will answer your questions as we go. This session is being recorded. We will share the recording link and a presentation deck after the session ends. Now, without further ado, we will turn time over to Anurag.
Thank you, Jocelyn. So hey everyone, Anurag here. Have a great session lined up for everyone today, so looking forward to presenting it. I'm going to go ahead and turn off my camera until Q&A at the end. So let's talk a bit about the agenda. What are we going to walk through today? So first, we're going to give an overview of what the Elastic Stack really is, talk a bit about observability and the use case, and then talk a little bit about the Elasticsearch service. While I'll be giving this presentation and talking through some of these use cases, it's always helpful to see how users in the real world are using that. So we'll give a quick walkthrough about that. And then the last two components, we're going to talk really deeply about some of the feature sets that come with the Elastic Stack around observability, and then how we can augment those features with Elasticsearch service and simplify scaling to petabyte scale. And what's always helpful is during the webinar, you can listen along, but I also always encourage folks who like to play along can sign up with our cloudelastic.co for a 14-day trial, spin that up while I give the presentation, and then have that something to play along with as I walk through it. And after we're done, you have that along as well. So without further ado, let's talk a bit about Elastic products. And for the first product here is the Elastic Stack. So the Elastic Stack at its very core has Elasticsearch, this search engine that is storing, searching, and analyzing all of the data that's being input. And as you have this core engine, you need a way to visualize that data. You need a way to manage it, monitor it. And Kibana is that visualization, that window to Elasticsearch. Now, we also need to get data into Elasticsearch, and we also need to do that reliably and consistently. So with that, we have two great products, one being Beats and the other being Logstash. Beats you can think of as lightweight shipping agents that live at the edge, maybe something on a server, maybe something within a container, and Logstash being something a lot more powerful, something that can take all of these various data streams coming from edge components, can take data coming from a server itself, can pull data from relational databases or other sources, enrich that data, and then send that off to Elasticsearch at very high speeds. Now, to deploy the Elastic Stack, we have a number of ways. The easiest, and the one we'll go into more depth, is with Elastic Cloud. We have a number of solutions, whether it's focused on application search or site search. And then the Elasticsearch service, which also lives under that same umbrella. From a self-managed perspective, we've brought the power of our cloud, something that you can deploy privately onto your own infrastructure, whether that's bare metal, whether that's in AWS, Azure, Google, wherever you may be. And then, of course, you can individually download each component and run that as well. So next up is solutions. What we've done over the past couple of years is we've really seen Elasticsearch being used for a variety of use cases, whether it's logging your applications, whether it's for searching your application, whether it's for being the center cornerstone for your website. There's a number of different use cases, and what we've been able to do is provide very solution-specific ways to interact with that use case. Produce a visualization such that logging becomes much easier, metrics become easier. APM is something that you can start to understand from a data perspective. And so each of these solutions have different ways you might interact with the system, but all of them being built on top of the core Elastic Stack. Now, when we talk about observability, what do we mean? Observability is this newish term that has been brought up by companies like Twitter, like Google, based off this concept of site reliability engineering. And that's really for keeping very high service level agreements or SLAs with customers. And when we have these really strict requirements of uptime and making sure that services are available, we need to monitor all pieces of that application, whether that's from a developer perspective, monitoring the application itself, monitoring the infrastructure, the underlying infrastructure, the app infrastructure, monitoring metrics that may be custom built, that may be infrastructure specific, that may be container based. And then lastly, logging. How do we make sure that all of the information that is being generated across a variety of places is somehow centralized and viewable? Now, each independent use case traditionally has their own tool. And within an organization, what you might find is an APM focused team, a monitoring focused team, metrics and logging focused team. And while these tools might be great at solving the specific use case, what ends up happening when you have an issue is it's very hard to diagnose and troubleshoot where it may be arising from. So with the Elastic Stack and observability, what we've done is using that same core engine, provide 4 great solutions so that you can centralize from a team perspective and really gain a coordination and cohesiveness as you troubleshoot, allowing you to really dive deep into the issue and resolve it quicker. So observability, once again, is really focused on solutions around the monitoring, APM, metrics, and logging, but providing that in a single interface that's easy to explore and use. So let's actually explore a real world use case for this. eBay, which does an online auctioning system, monitors petabytes of logs per day with Beats, one of our lightweight shipping agents. And what they're doing is running this on a next-gen workload running within Kubernetes. And as part of that, they're gathering all of these logs, they're gathering all of these metrics, and they're really going over 100 billion URLs, 100 billion messages, just this immense amount of data. Now, all of this is something that they're able to capture insights on and troubleshoot faster, and having both logs and metrics in the same place provides quite a big benefit. So highly encourage folks to go to elastic.co and view the full session that was given by eBay. But one thing you'll learn in that session is that eBay has a dedicated team to Elasticsearch, a team that's managing and deploying and operating Elasticsearch. Now, all companies can't be as lucky as eBay, and so for that, what we have is the Elasticsearch service. And this allows you to offload all the operations, management, and give that to Elastic for us who have been managing and operating Elasticsearch, Kibana, Elastic APM server for a number of years, and allow you to focus very much on the business value that you drive through your application. And what Elasticsearch service does is it makes cluster management very easy. You get one-click deployments and upgrades. So any new versions, such as the brand new 7.0 release a couple weeks ago, you now have access to. You're able to scale up and scale down from a very easy slider perspective. If you need more data, you need more space, you need more performance, that's available. And then we also have secure concepts like auto backup and auto security configurations. So that way your data is safe and it is encrypted both at rest and in transit. We support 9 regions on AWS and 4 regions on GCP today. And we also offer a number of different ways to cater to your specific use case. So whether you're going for a logging and observability use case with hot warm, or maybe you're going for a very compute heavy or machine learning use case with CPU. Both of those are supported as part of Elasticsearch service. Now the last bit here is Elastic has created brand new features and really highly innovative features that both scale the solution set as well as the base core functionality. These are presentation layers like Canvas, where you have an auto-updating infographic UI. Elasticsearch SQL, so you can quickly adapt to how Lucene search syntax comes from, but with a familiar way through SQL. Rollups and graph, to, one, allow you to really shrink your large data sets that still retain the granularity that you might need over time. Graph to give you insights on relations between your data that you may or may not know exist. Machine learning for anomaly detection. Security, both in the context of authentication, as well as authorization from a role-based perspective, as well as field level security as well. Alerting, monitoring, and a number of other solutions that pair nicely with the whole observability set. So Elasticsearch service provides these features and is really the only hosted Elasticsearch solution that does so. Because Elastic produces these features, we want to provide the best experience for them, and we do that through the Elasticsearch service. So with that, I'm going to quickly showcase what the Elasticsearch service looks like. And so here on my screen, I'm on the central deployment page. And a deployment you can think of as being Elasticsearch, Kibana, as well as APM. And with this, I can go ahead and create a deployment. So if you are signing up for a trial or you've signed up for a trial, you can go ahead and spin up a cluster today. And we can go ahead and give this a quick name. We'll say test monitoring. We'll deploy this in Asia Pacific. We'll choose the version. One of the greatest things here is that the same day the versions are available for download, they're available as part of the service as well. And then we can choose our deployment. So we can choose something like hot and warm. Now, once we choose that, we can start to customize fault tolerance levels. We can choose things like RAM per node. We can enable things like machine learning that we also offer a 1 gig node absolutely free. We also offer a 1 gig node of Kibana absolutely free and a 512 megabyte server of APM server absolutely free. So these are just some of the ways you can go ahead and configure the deployment. And we'll talk a little bit more about hot warm specifically as we move into the session. So with that, let's return back to the presentation. Now let's talk about how do you get data into the Elasticsearch service. This is really important as we want to be able to have a ton of data in there so that way our observability scenarios are worthwhile and have a lot of context and meaning and really help us resolve the problem. Because if the data doesn't exist, then we won't be able to troubleshoot it or link it to any of the related data that may or may not exist. So with that, let's talk a little bit about some of the data sources that exist. And these are, again, coming either through Beats or Logstash. And we have a number of ways that you can just take in raw documents or raw log messages and pump those to the Elasticsearch. But we also have plugins and ways to grab data from very known data sources, whether that's from containers and cloud sources, so something like AWS CloudWatch through what we call our function beat, or something even more well-known like a security device that has a proxy with a custom event format. All of these various data sources and all of these different styles can get integrated and ingested into Elasticsearch. Now, to build on top of that, one of the other primary ways that observability can be done is through what we call Beats modules. Think of a Beats module as packaging all the way through from ingestion to enrichment to visualization to even higher fidelity pieces like alerts and machine learning into a single package that you just enable on the source. Once you do that for a well-known data source, all of these insights are going to be available to you via a Kibana dashboard. We do a number of these today. Some of them are listed below. And so having this visibility from ingestion, being able to grab this data is really just going to continue to help augment any of those observability scenarios that you may or may not need to do. So let's dive a little deeper into observability and Elasticsearch service. So one of the big things that we've released over the past couple of Elastic Stack releases is a number of features that are very focused on this solution area. The first of which is a logs UI. So if we think about logs, what you traditionally had was Kibana Discover or something just to have all the logs visible. Now with the logs UI, what we've done is say, why don't we take that same file format as if you were tailing a file and bring that into the UI itself? Maybe you want to stream those logs as they're continually being pushed through to the service. And as they're being streamed and pushed through the service, give you that same super fast search on top of it to quickly look into logs and look at context with logs. So now you have this very focused logs UI that allows you to search, to stream, as well as really pinpoint any errors or things coming together. The next is infrastructure UI. So this is another big investment that we've done, and it really provides a top overview of what's going on from a host perspective, whether it's a server level, a Kubernetes perspective. So once again, those next generation workloads that you may have running, how do we bring immediate value to that and allow you to go through and visualize and look at all of the various elements, group them, and start to troubleshoot, whether it's a color coding of saying, this looks primarily bad. How do we allow you to take the context of infrastructure, switch into logs, switch into metrics, and even switch into application performance monitoring. So this has, once again, been another place where we've heavily invested a lot of time in making sure that all of this adapts well for your specific use case. So APM, let's talk a bit about APM, application performance monitoring. So APM gives you end-to-end visibility on transactions. So whether you're looking at Java, Go, Ruby, Python, Node.js, real user monitoring, or RUM, you have support for embedded agents that can instrument those instruction sets. And as they instrument it, you'll be able to view a single trace as it goes through an application, talks to a database. And this is once again, very useful as you look at distributed services that might not exist at a single point. And as you look at these distributed services, you're going to want to integrate with metrics. How does the downstream metrics look like? How do logs look like? And so having all this data again in the Elastic Stack is very important to really solidifying what is going on, how do we resolve it, and also ensuring that you have proper context as you diagnose with either partner teams or teams that sit within your own organization. So with that, what we're going to do is go ahead and look at a quick demo of those three data sources. So what I have here is a sample email box. And if we look at what this is looking at, it's really monitoring a service that is deployed on some of the next-gen infrastructure, like say Kubernetes. We have this service that is running web servers, running application servers, and all of this data being routed to Elasticsearch such that we have full visibility or full observability across the entire solution set. Now, unfortunately, we've seen a poor performance alert on top of this server scenario. So what we would do in the traditional sense is perhaps get on a phone call with all of our various application teams, potentially start to say, okay, tell me what you see across all these various tools. But because this organization has really centralized on the Elastic Stack for observability, what we can do is really perform a variety of steps that can, not one, just help us discover this issue, but two, how do we switch context very easily and provide any of those incident owners the full visibility that they need to correctly triage where this alert or problem may lie. So with that, we can go ahead and click this link to investigate further. And what this is going to open up is actually our machine learning interface. And machine learning in a traditional sense has been pretty complicated for a lot of folks to use. A lot of companies and organizations may have a machine learning initiative, but getting started with machine learning can be somewhat troublesome. It is something that is not very easily accessible, but with Elasticstack's machine learning and that machine learning that's also available in the Elasticsearch service, what we've done is made this something that's very simple to approach and simple to use, but gives you a high fidelity and complex results that are easier to parse than what you may expect when using something like a machine learning specific solution. So here, what I'm showing is an anomaly explorer. And if we think about alerting and how do we find issues, there is a very fundamental way where we might look at a specific performance alert or threshold crossing and then have a routing of an issue. But what machine learning can also do is look at the data over a long period of time, automatically create a model, and then highlight any anomalous results. So that way, as an investigation owner, I'm not just looking at thresholds. What I'm doing is looking at anomalies that exist within my system. And I also get some context as to why this is rated as an anomaly and how I can go and start to solve for this. So for example, if we go look at anomaly, we can say, I have this anomaly score of around 95 here at 12 a.m. And if I go ahead and click on this, I'll automatically get some context as to what's going on. But this is not enough context for me to fully go ahead and start to diagnose what has truly transpired. So instead, what I'm going to do is click some of these actions. Now, because I have all of these various data sets within this one Elasticsearch service deployment, what I'm going to be able to do is first look at it from an APM perspective. So I can click into APM. And now that I'm in APM, what I can look at is, oh, I have this really high increase in response times. And as I see this increase in response times, what I'm also noticing from the context-aware UI is that from a request per minute, I actually haven't increased. So what I'm seeing is an increase in response times, but my requests, there isn't an overload of customers. So next what I can do is look at API owners and this specific request call and view it from a distributed perspective. Because I have two services, I can take a look at what's going on from a select perspective. And this is a traditional way that selects may work from a Spring application, calling multiple different select statements. And so what I can also do is click and see a full stack trace. And as I look at that, I can also look at some of the various ways that the response time is coming in. And if I want to, I can also view this transaction discover. So while here I've been able to look at APM, what I now want to do is start to look at this from a perspective of how does this look over a period of time from an infrastructure perspective. So we'll just go ahead and quickly navigate back to the machine learning piece. And what I'll show you from there is we're going to go ahead and select the infrastructure UI. And so once again, we can see the anomalous behavior. This time, instead of clicking APM, what I'll do is click infra analysis. Now from the infrastructure analysis, since this is running on top of Kubernetes, we can quickly see all of the various containers, and we can see any of the highlights as to how much percentage of CPU they may be using. If I want to look at this from a pure host perspective, I can do that as well. And this really allows me to quickly start changing the way I'm viewing all of these metrics and how they populate to something that may be going on. So from a pure container point of view, this looks fine, but as soon as I switch to host or maybe Kubernetes view, and if I want to group by, say, something like per node, now I have a little more context in this visualization. So what I'll do is I'll go ahead and say, I'm going to go ahead and look at, say, something like logs. And if you think about a container-based solution, you may have thousands and thousands of containers. And if we can quickly highlight any problematic hosts and problematic containers, the ability to jump to those logs is extremely powerful, because as those logs are being generated, they're also very ephemeral. Docker in nature is something maybe that's short-lived, it's not continuously running. So having this ability to quickly view history of that container ID over time and being able to jump to logs is very powerful. Now, nothing in the logs looks specific. So what I can also do here is switch into the metrics portion as well. And as part of the metrics portion, I can look at overview, CPU usage, memory usage, and network traffic. So all of these different aspects that might exist across this pod, and really start to gain some insight as to why this might be happening. And it looks like it auto detected for April. So let's actually go switch this back to the context of November here. And when we do that, hopefully what we'll see is these metrics that were as part of the initial piece. And let's go to the 25th. And then we can see some of the CPU usage and memory usage of that specific container at that time. So once again, jumping from an anomaly alert that's machine generated, then going into APM, and then switching from APM to metrics, and switching from metrics to logs, all of this is part of that journey and having that capability for overall observability within Elasticsearch service deployments. So with that, there's another big piece here, which is uptime monitoring. So this is a brand new as of 6.7. And what this does is add another layer, which you can start to check as well. And this is for looking at any of those services that you may have that are accessible either by HTTP, HTTPS, or TCP, and give you this overview of how they're running over time. And now you have all of these different elements of data. You're running machine learning on top of all of them. You're automatically detecting alerts. You're automatically finding anomalies. And then once you do find those anomalies, you're alerting and getting the right people involved. So this is really part of how do you grab all this data and really make use of it as part of the Elastic Stack and Elasticsearch service. So with that, I want to switch gears and talk a bit about how the Elasticsearch service simplifies the scale of these operations. Because what we saw was a very simple, small use case. But in the case where you may have terabytes of data flowing in, or even petabytes of data, you really need to be sure that the cloud platform is going to scale to that size. And from a cost perspective, you're also set so that you're not necessarily paying enormous costs just to host all these metrics. And so one of the benefits that Elasticsearch service has is what we call hot-warm architecture. And hot-warm architecture is this great, powerful thing that is exclusively available on the Elasticsearch service that allows you to store recent data, say 7 days, in hot. That's backed with solid-state drives, NVMe local drives that are extremely quick to query. And then as that data ages and becomes less relevant from a time perspective, move that over into a hard disk drive such that it's not as cost prohibitive to store over a long period of time. And now with index lifecycle management, a feature that has been brought to Elasticsearch service as part of 6.7, we automatically allow you to configure these policies where you may have roll-ups after a set period of time, where you take those gigabytes and gigabytes of data and shrink it down, or move it from hot to warm based off of time or based off of size. So these two tools as part of Elasticsearch service and how Elasticsearch service augments index lifecycle management are great ways to reduce total cost of ownership for some of those longer retention workloads. The next bit is another stack feature that's still in beta, which is Beat Central management. If you think about all of those various endpoints, if you have 10,000 endpoints, 100,000 endpoints, all filing data repeatedly, what you want to be able to do is have the ability to modify and delete configurations on the fly and get some sense of how all of these edge agents are performing. So this is another feature that is part of the Elastic Stack that you can utilize in the Elasticsearch service exclusively. And we support FileBeat, which again has all of those modules and inputs that I mentioned before, as well as MetricBeat. So with that, that kind of goes over all of the various feature sets, observability in Elasticsearch service and the Elastic Stack. So what I would love to say is, please sign up for the 14-day trial. You don't need a credit card. You're able to start ingesting data as soon as possible. For those who are at AWS Summit Sydney, Elastic is there as well. We're at booth R11. It's from April 30th to May 2nd. So definitely come and visit us. We're all waiting for you. And lastly, from a further reading perspective, there's a ton of more information about each solution independently. There's blog posts about observability and how to go about enabling that. So recommend reading some of those and getting started. So with that, I'm going to go ahead and switch into Q&A. So I'm going to stop sharing. And I'm going to turn on my camera. And it looks like there are a couple of questions. So the first question is, can you explain a bit more about the differences between AWS Elasticsearch and the Elasticsearch service? So this is a great question. A lot of users come and say that they think that AWS Elasticsearch or Amazon Elasticsearch is provided by Elastic, and that is actually not the case. So as Elastic, our way of providing that service is through the Elasticsearch service. And AWS Elasticsearch service is just based off of what we provide to the community as open source. So there are quite a bit of differences there. What you've seen over the past year is a number of investments, either in things like Logs UI, Infrastructure UI, APM UI. All of the uptime monitoring is there as well. We also have things that are like Canvas to visualize all these elements in an infographic fashion. And then there is also ways to look at things like SQL from a security perspective. And then lastly, from a purchasing perspective, because we offer some of these really cool hot, warm, dual architecture type ways, we can be really competitive when you look at things like a TCO point of view. So I definitely mention those as being some of those key differences. Highly recommend you taking a look at our service, at least trying it out and giving it a shot. Next one is, you mentioned hot warm architecture. What are the benefits of this? Yeah, so this is a good question. Hot warm is, once again, really these two distinct ways of data. One being this hot tier, recent data, SSD backed, and in a warm tier, something that's a little more cost efficient and storage optimized. So if we think about RAM to disk ratios, you might have 1 gig of RAM for 30 gigs on a hot cluster. And on a warm, you would have a 1 gig of RAM for 100 gigs of storage. So you can think about that 1 gig of storage cost being tremendously lower on the warm tier. And then the trade-off there is your search is maybe perhaps not milliseconds, but maybe a second. It's still amazingly fast because that data is pre-indexed, but you can start to build much larger retention periods over longer periods of time and still retain visibility, which is really key for some of these audit scenarios, whether you're going through Sarbanes-Oxley compliance, looking at PCI compliance or SOC 2 compliance, which Elasticsearch Service has, SOC 2 Type 2. And these is a great way and a great difference that exists between our service and some of the other services out there. Third question, how often are new versions of the Elastic Stack released? Yeah, this is a great question. You can see we released 2 new versions within the past couple of months, 6.7, which comes with uptime monitoring, and 7.0, which is the next major version, really big release for us. And all of these new versions, it's important to note, as while we're continually building them, the Elasticsearch Service 1 makes it very easy to upgrade. It's a simple button click, and then the service will go ahead and orchestrate all of it for you. It will move over all the indices. It'll make sure that the endpoint is still available, ensuring very low as little as zero downtime. And then for that zero downtime, as long as you're across 2 availability zones or 3 availability zones, being very fault tolerant to any hiccups that might occur as well. And all of that being available day 1 as part of Elasticsearch service. And so let's look at some of the other questions here that I could just go through as well. What is the pricing model of Elasticsearch service? Yeah, I think this is a great question. I would recommend going to elastic.co/pricing. And I see Stuart's already answered that question. Next question is, how does this compare with Datadog? What are some of the key differentiations? That's a great question. Datadog, if we look at it from a monitoring perspective, is really focused from that pure metrics angle, and now they're starting to offer aspects like logs, etc. If we look at the Elasticsearch service and the way that we're allowing you to have that data, it's not something that's based off of a transaction or storage or a metric unit. What it is just based off of all the data. So, we think about a general purpose platform and all of the use cases that it can support. Elasticstack is a lot more flexible in the sense that you can really play with their data. You have full access to it. If you need to delete it, you can. You have some really high level integrations with graph and machine learning. And then, from a cost perspective, since you're paying for the underlying Elasticsearch resources, store away as many as you want. It doesn't matter how many metrics. It doesn't matter, how many logs, as long as the storage and the resources are available to you from Elasticsearch perspective, you can do a lot more. Okay, so yeah, I think that is all the questions I have. We can look at any of the other ones here. I believe that is it for right now. So thank you everyone for joining. I really appreciate the time today, and I do hope you try out our Elasticsearch service trial. And yeah, we'll look forward to seeing you on the service. Thank you.